Just testing. Yeah, OK. Hi, everyone. So Manfred from gno.land, blockchain we are currently building in the Cosmos ecosystem, inspired by Ethereum and the smart contract era. So, oh, I think the remote has a problem. So yeah, I started building cloud computing things in the Web2 world by building Scaleway. Then I created privacy and anti-censorship protocols with Bertie, and now I'm building anti-censorship resistance infrastructure ecosystems with gno.land. And the goal of gno.land is to try to push the barrier of what we can do with Web3 dApps. Building blockchains was a good step, but we strongly believe that basically the future of Web3 will be with dApps. So once we will finish building the good blockchains, I expect most of the developers to actually build good dApps. dApps we need, dApps people need, dApps people depend on to survive or to just scale. And I want to show you some unique features of GNO that, in my opinion, could push dApps development to the next level, especially regarding the interoperability and composability of dApps. So GNO, a single word, but actually we have two things behind. One of them is GNO, the VM, the language, allowing to basically write applications with a simple language. It's Go. So it's not a new language. It's also very powerful with a lot of actual developers, a lot of tools, a lot of knowledge. It's a very good, simple, strong language, but it's not running on blockchains by default. So we created GNO. It's another language. It looks like the same, but it has determinism because it's needed by blockchain. It has state persistency because it's just a nightmare to have to manage databases and files in the context of the blockchain. So basically, it's the exact sweet spot between Ethereum, Solidity, and Golang. And it offers some features that, in my opinion, are not possible in other languages right now. gno.land, the blockchain behind, will be the first blockchain using GNO, but in practice, it's a VM, so you can expect other blockchains to launch with the GNO language too. This first one will have three main unique features. One of them is to not use proof of stake or proof of work, but another mechanism we are creating. Internally, we name it proof of contribution. Maybe the name will change, but basically, it's a mechanism which won't rely on money and won't be subvertible. We are using Tendermint 2. So if you know Tendermint, that powers most of the Cosmos blockchains and other blockchains, we are creating a new version. So we are the original authors of Tendermint 1. And we'll also try to innovate in the IBC and ICS world, so how to connect blockchain together, how to make interconnected blockchains so we can have independence and collaboration. It will also be a new hub, because as you will see, one of the things we want with GNO is to push the open source spirit as much as we can by enforcing transparency, reusability. And for this, we need a hub, like GitHub for the open source Web 2 world. So a simple contract, hello, not very useful, but this is a full contract. If you upload it, actually you won't upload the binary, you won't upload the bytecode like in Solidity. You will upload the source code. The source code will be something you can introspect. You can read the source code, you can verify. You can also just interact with it. You can interact with the wallet, and you can interact with other contracts. Here we can have a more advanced example. It looks like Solidity in so many aspects. Actually, it looks like more Solidity than Go, because in Go you cannot just do this. In Go you cannot have a counter who will be incremented and persisted across executions. If you run a program in Go and it stops, all the variables will be reset. But in GNO, as in Solidity, we have automatic persistence. So where Go would be not ideal usually for blockchains, and where Solidity is Solidity, so a new language limited to this and with the current limitations. Here you have a good sweet spot with readable code that is also more powerful than Go for blockchains, including automatic persistency. If you call increment 10 times, the counter will be equal to 10 because the persistence is automatic at the end of each transaction. The same example, counter, but this time I introduce another concept, which is a private helper. Add to counter is a private helper, meaning that People cannot interact with it, but the contract can use it. So this simple concept allows you to create an API, Ink and Add, who are both available for wallets and other contracts. But under the hood, they are using a private helper. So in practice, you can draft your API contract, design it, secure it, ensuring that you have everything you want for all the actors with the level of security you need, while having all the helpers you want. Another example, which is a little bit more advanced, because once again, I think one important thing with auto-persistency is when it's not limited to primitive types. A primitive type will be an integer, a string, a boolean, a float, but here we are storing a tree, so something with structs and pointers and nested structs and recursive pointers, so just a nightmare in most of the languages. Here we are storing a tree, so each time a new post is added, you will create new nodes. New node just save the node, update previous ones to change the directions. So an advanced data type in Web3, which is actually very common in Web2, becomes possible on GNO, and allowing to have this full contract to let anyone post a single comment and everyone to also view all the comment without paying a transaction. The render function is something you can query without paying gas, allowing to basically have the web rendering part included in the contract. One language, one logic. You don't have a logic for the database, you don't have a logic for the rendering. One language, you do the storing, the logic, and the rendering. So now, let's speak more about the interoperability of the dApps. One key thing about Web3 dApps is not only to provide the dApps, but to make the dApp interconnected or interconnectable with other dApps in the same blockchain or other blockchains. Here you have two contracts, Alice and Bob. As you can see, Alice is basically like the counter. It has a global variable, a getter, a setter, but it's relatively stupid. Bob imports Alice, and import is, I think, the important point. In most of the other Web3 ecosystems, the sandboxing won't allow you to import something. They will allow you to call something, to basically open like a tunnel to another thing, which can be a contract, another blockchain, and transfer like parameters and expect a return. Here you have an import, so as for Go and actually every other languages with import support, you have all the type definition, the compiler part understands all your dependencies, and you can call them. So increment Alice in the Bob function will actually make two different calls. One of them is to get, so it will call under the hood the Alice contract to get the value, and then it will call the setter. So in this simple example, you have two calls that are actually very, very cheap. You can imagine GNO to be something where it's not something you try to avoid to go from a contract to another. It's very common to call another contract 10, 100, 1,000 times in a single transaction. We have two kinds of packages. One of them are the pure packages, so they are stateless, but they are focused on reusability. This part defines what we expect the GNO hub of source code to be, because the goal is to encourage people and to incentivize them to write the best code. So basically, we want to pay people to write good code. Once they write a good code, the code will be imported. To this time, not create packages, but realms. And realms will be smart contracts with the state. And the realms can import the pure packages, and they can interact with other realms. So two kinds of packages. Under the hood, one of them is stateless and pure. The other one is stateful for the dApps. It's like you have the App Store for the users and the repo for the developers. So an example of package, gRC20, the equivalent of ERC20 on Ethereum. This one is a pure package. It doesn't have a state, but it defines an interface. It defines the structures so that you can create your own token in your realm. So the gRC20 package is imported everywhere you need to either just use the interface or if you want to create your new token. And here is a realm I published today on-chain. So there is a BUIDL 20 token available on-chain, and this token is importing the gRC20, calling the constructors, new token, exporting everything, minting 1 million tokens to the deployer, to myself. And this is an example of a realm, BUIDL 20, calling a generic reusable code. So it's not like a dependency you have on Solidity or other languages that you fetch on your computer. you publish your dependency on-chain, and then you publish a contract on-chain that will import the dependency on-chain. So it's not about fetching dependencies and building a binary. It's about just publishing source code, which sometimes is just helper for developers. Sometimes it's an application. Another good thing with GNO is the notion of safe object. The good example is for the tokens. On Solidity, the most common way to create a new token is to publish a contract. On GNO, you can create a contract that will expose a token, but there is another way to have something equivalent, to have the notion of dApps, which is not to write a new contract, but to create a new object, an instance. So a single contract, a single source code uploaded 10 years ago can create new objects over time, which are all independent dApps. A safe object is basically a dApp. It's like a bubble, a sandbox, that you can give to any other wallets or applications. So if you provide the pointer to another contract, you can safely be sure that your object will be secured by your API. If you have internal variables, they will stay internal, but you don't care who is calling it and who is storing the pointer to the object. And then you have an example of registry. A registry is basically taking an interface. They don't know which token will be registered, but they know the interface. They register something, and they allow anything to get it by a string. By this single pattern, you have all the DEX, atomic swap, and other systems that will rely on of being aware of a token, able to not import the token or to know a 0x something address, but just to use a human-readable token name. So this is because we can store the pointer to something, and this something can be a contract or a GNO-safe object. And the friend contract is the opposite, the factory. Registry is about storing pointers to existing instances. Factory is about uploading the source code once and then creating 1, 2, 3, 1 million tokens using the same contract instance. So everyone who wants to create a token, they define a name, a symbol, blah, blah, blah. And the contract will store locally an instance for this GRC20 token. So with these two contracts together, basically, I can make with my wallet just a transaction calling new with my name, my symbol, and it will be created, managed by the factory, but also registered on the registry. So with a single transaction, a call, basically I create a token which is registered and available in the ecosystem. An example of type safety also is we want to make it impossible to basically have to manage the dependency like this in Solidity. We definitely want the type safety to always be safe, always be obvious. We don't want to have something where you can try to hide complexity or hide bad code. So this, instead of this, we definitely just want to use the interfaces, the normal Go and GNO compiler protections. So here I can create a DEX, and this DEX is just taking 2 instances of a GRC20 interface implementation, and it doesn't know what is this token. It doesn't know if the token is actually a valid one, but it will be able to just use the expected methods and structures and types with a strong type safety. So it's basically impossible to call placeholder with something which is not fully compatible with a GRC20 token. Another good concept for interoperability and composability will be the notion of posable closures. So basically, you can create like a thread. This thread will be paused and stored somewhere in the blockchain. So you can imagine having a proposal to apply some arbitrary change, and you store the pointer to the change executor on the blockchain. Then you make your DAO proposal, and 3 weeks later, someone will hit resume and execute the thread. So this is an example of closure. You create the closure, you store it. This is a transaction, and maybe 1,000 transactions later, something will execute it. And when it will be executed, it won't be executed with the context of the executor, but the context of the initializer of the proposal. So you can create a proposal from a DAO, from a user perspective, You can lose your private key, but it will be able to be played later by someone else. And here it's about having arbitrary code execution. So here we import gov.dao. Gov.dao is a DAO unaware of any change. It's not aware of what is a GRC20 token. It's not aware of anything else than itself. It knows that he has members, that how to manage a vote. But the goal is to ask this gov.dao to safeguard all the proposals executing arbitrary code. So arbitrary code in the context of gov.dao, in another contract, or even on another blockchain. And now, when you have this notion of type safety, of composability and everything, you can start creating funny stuff. One of them is if you have an interface for a DAO, so something where contract wallets can propose new things, list the proposals, execute them when they are passed, you can expect to have some basic implementation. So one of them is a stupid implementation, basic one. But you can also expect to have composition. So here is an example of aggregation of DAOs, when in practice, the aggregated DAO is still a DAO. It still implements the same interface. So as soon as you can register your DAO somewhere in a registry, in whatever, they will be able to receive the pointer to your simple DAO or to an aggregated DAO, so basically a wrapper to here two DAOs. And it will be transparent because it's how GNO is working with composition. As soon as you implement the interface, you can do whatever you want. So here is basic aggregation. And it was a library. So here is an example of foo-bar DAO. Foo-bar DAO is aggregation of foo-DAO and bar DAO. And as you can see, this is a full contract. I implement the aggregated DAO library, the two realms, foo and bar, and together I create a new DAO, which is a valid DAO that will depend on two DAOs. So some examples of potential DAO composition we can try to do with GNO. We can have things that are purely about, for instance, making a proposal that will depend on having 60% of votes for DAO A and 20 from DAO B, or something where you want to wrap an existing DAO so you don't change the under the hood rules, but you can maybe add a notion of delay or security or something, a system of fallback. If DAO A takes too much time to make something, then you have DAO B to be able to finally make the proposal happening. And to finish, we are launching soon the chain, and I wanted to just show you what we do here, what we do with GNO, especially in comparison with Solidity. In Solidity, we are building millions of dApps. If you believe that at some point having potentially more built-in composability features in your contract, also having by default a high level of transparency, of reusability, and basically having a way to receive money by just writing good code, by writing good reusable code. You can try to basically port your Solidity code on GNO. You can try to build your next application on GNO with this goal of both growing the dApp store on the one side and growing the pure package, big repository of reusable content on the other side. So pushing the notion of open source with enforced transparency, enforced source code discoverability, but on a blockchain which is not using the bytecode, the binary, but directly getting the dependency, understanding it, having the type safety. So basically, you can only create new stuff that works with the whole rest of the whole blockchain. It's not possible to create something that won't be compatible with the rest. So imagine just a big shared craft location where we can all build new blocks that are interconnected by default and just expand the possibilities for developers and for users. All the information are on gno.land, and if you have questions, I will be there for 2 days. Thank you.
Thank you very much.